discussion. So, take a look at this graph. It's histogramish, but it's not a histogram in the way we're used to seeing it. How is it similar and how is it different? How is it similar and how is it different from the histograms we're used to seeing? Richie, give me similar or different?
Single data points.
Good. So it's similar in that we've got 20 pounds, 21 pounds, 22 pounds, 23, 24, and so forth to 33. Perfect. That's how it's similar. But if that's the same, how is the shape so vastly different than the previous? Previous one, you remember the previous one, it went like this, and then it kind of went like this and then dropped off again. What do you see here? Say that again. Look at how the vertical axis is described. It's not good, Michelle. It's not the number of boys at that weight. It's the number of boys at or below that weight. So remember, there were 3 kids. I think there were 3 boys that weighed 20 pounds, and there's still 3 boys that weigh 20 pounds. Then I think there was 1 boy that weighed 21. So now this bar goes to 4, because there are 4 boys that are either 21 pounds or less. Then there were 2 kids at 22 pounds. So when you add that 2 to the bar before it, which is everybody below that, you get that height of that bar. Do you see the difference in the numbers on the vertical axis? It goes all the way to
100.
100, because our little friend that was 33 pounds was the heaviest kid in the group.
So there's 100.
Go ahead and say it, Lord.
There's 100 on the.
There are 100 of them.
Way less than him.
Exactly, that are either 33 pounds or less. Now, I'm not saying this is always useful, but it's sometimes useful. If I asked you to find Max in this one, would it be easier or harder?
Easier.
If you knew he was the 80th percentile.
Easier.
Much easier. All you've got to do is find the bar closest to 80, which in this case is right here,
31.
and realize that these are the kids that are lighter than him. So if 30 pounds and below represents 80% of the data, that means Max has to be in this bar, the next bar up at 31 pounds. Piece of cake. That's why when you go to the doctor's appointments, they give you this. Whoops. This. They hand you this, which is essentially, it's a fusion of that histogram plus what's called an ogive. Don't memorize this, it's not that important. It's the histogram in line form, which looks like, now this looks hellishly confusing when you first see it. But then you realize how much information is crammed onto it. It's freaking rad. So you've got birth to 36 months for boys. This is white American males. It's a little bit less than by the CDC. By the CDC. Okay? Birth, 3 months, 6 months, 9, 12, 15, 18, up to 36. There's your 3 years. Here's Max at 24. Now, I did this exercise a little bit backwards. They actually had his weight first, and then had his percentile. We went backwards. We went from the percentile to the weight. So what they did was they weighed the dude, and they said, okay, it's 31 pounds. What's his percentile? So they went to weight, pounds, 31 right here, and then they came across until they hit 24, which is right there. Now this is a little bit hard to see because it's not designed to be this big. This is the 75th percentile line.
Oh.
This is the 90th percentile line. So they called that 80th percentile because it's roughly a third of the way across from 75 to 90. Ish, I don't mind that at all. What I minded was the interpretation of what it meant about my little man. Now, Rory, you mentioned about the tails. Notice the highest percentile labeled is 95. The lowest percentile is 5. We've lost the bottom 5 and the upper 5. They're not even indicated on the chart anywhere. I don't know where they are. I'd have to know what the heaviest and lightest 2-year-olds are, and I have no idea what those are. And that's kind of the point. They're going for the middle. Now, take a look as you go from the 24 back to birth. What happens to these lines? This is why when kids are very, very, very young, it's very, very, very easy to be off with where you put your pencil dot on. This is a piece of paper they hand you. They hand you the paper, they put the pencil dot on. It's a very large dot sometimes. And you can be off quite a bit. I mean, if you put the dot here and you're off by, a couple millimeters, that might be off by 10 percentage points early on. So, proper size grain of salt, and mathematics will help you. The more of the math that we're going to do later on in the course to get more precise results. But this is an idea. I mean, this is the ogive or the cumulative histogram idea presented to you. I've seen these go out 20 years. 20 years. Somebody in the last class goes, how do you judge standard deviations from this? There's no standard deviation on this. I said, you're right, there is no standard deviation, but you can get a ballpark. You can figure out where the middle 95% are and realize that's 2 standard deviations. I actually have a quiz for you guys coming up the pike that's going to ask you to do that. Off of this chart, approximate what the standard deviation is for my 2-year-old son based on that chart. And you can do it. You can reverse engineer it from this chart. Kind of fun. If you assume a bell curve, which it sounded like you guys were okay with assuming they were bell curves from before. Yeah, assuming a bell curve, you can actually reverse engineer. So I'm going to have that as a quiz for a couple weeks out. Cool? All right, but yeah, I sense you guys are getting bored with the damn baby talk. So, take your data sheets out. Take your data sheets out. Read this. Let's stop and restart.